Hello, Ms. Reams here again. Hey, I made this video to help you out with your practice assignment. So there's 4 different parts, part A, B, C, and D, and so I have an example from each section. Okay, so if you need some help, check out this video. All right, in part A, it says find the coordinates of the vertices of each figure after the given transformation. So we're going to dilate, it would probably be a triangle with these 3 points, but we don't even need to draw it. We just want to figure out what the new coordinates would be. What would C prime, D prime, E prime be after a dilation of 3 over 2 about the origin? So what I would do with this one is I would change, just to make life a little easier, I would change 3 over 2 to a decimal. So what you do to change it to a decimal is you do 3 divided by 2. Okay, or just use a calculator, that's fine. So when you do that, it goes in 1 time, 1, so it would be 1.5. Okay, so 3 over 2 is the same as 1.5. So remember what we did in the video, we'll take each point and multiply it by the scale factor. And here the scale factor is 1.5 or 3 over 2. So we're going to take and multiply each part by 1.5. Okay, and then we'll see what we get. Okay, that'll give us the coordinates for our image. So when we multiply negative 2 times negative 2 times 1.5, okay, we get negative 3. And so then we do it again, since it's negative 2, we would get negative 3 again. Okay, and the way that you do that is to multiply it, you could just use a calculator, or you could just do, it's negative 2 times 1.5. Okay, if you want to work it out by hand, okay, it would be like this. That's what 2 plus 1 would be 3. Move your decimal 1 place. It would be 3, and a negative times a positive is a negative, so it would be negative 3. Okay. So to get the next one, D prime, it'd be 0 times 1.5, which is 0. And 3 times 1.5, which would be 4.5. Okay. Like I said, you could just do 1.5 times 3. That would be 15, carry 1, 3, 4, move your decimal 1 place, 4.5. E prime, okay, it would be 3 times 1.5, which we already know is 4.5. And then negative 1 times 1.5 would be negative 1.5. Okay, so these right here would be the coordinates after a dilation of 3 over 2 or 1.5. Okay, so it's all just multiplication. It might help to change the fractions to decimals if you work better with decimals. Might make it easier to use a calculator. Whatever you need to do to work this out, multiplying by the scale factor. All right, the second problem is also in part A. This time we don't have the coordinates listed for us. We just have the figure drawn on the graph. So we have to find the coordinates ourselves. Okay, we don't have to perform the dilation, we just need to figure out what the new coordinates would be. So let's see, we have these coordinates, R, S, T, and U. And so what we need to do is multiply each part by our scale factor, which is 0.25. So we'd have to multiply by 0.25. Multiply by 0.25. Or if you'd rather work with fractions, if you like that, then it would be 1/4. It's up to you. Okay, so what we end up with would be r prime, and that would be 1 times 0.25, which is 0.25, and negative 2 times 0.25 would be, if you want to work it out, 0.25 times 2, 0, 1, 4, 5, move your decimal 2 places, and it would be 0.5, or because it's a negative, it would be negative 0.5. And then s prime would be 3 times 0.5, which is 0.75, and 0 times 0.25, which is 0. T prime would be negative 1 times 0.25, which would be negative 0.25, and 3 times 0.25, which is 0.75, and U prime, which would be negative 3 times 0.25, which is negative 0.75, and 0 times 0.25, which is 0. So these would be the 4 coordinates of the new image, and if you were to graph them, you'd have a small similar shape to what you have there. It'd just be reduced in size. But we don't have to graph it. You can if you want. Okay, so this one's a little weird, okay? So what we're doing is we're finding the scale factor of these two shapes from the smaller figure to the larger figure. So with this one, we want it to be smaller to larger. Okay, so when it's set up like that and they tell you smaller to larger, go ahead and find the corresponding sides. So these two will correspond, and then these two will correspond. And we don't know what goes with the 42. We know what side it is, but we don't know the length. So basically you want to go ahead and just plug in what you have. So pick a pair. I'll go ahead and pick the smaller numbers. So I would use the 15 and the 18. So the smaller would be 15 to 18. 15 to 18. Now we need to simplify that because it's really 15 over 18. So you want to simplify it. Okay, so we will simplify it, divide by 3, and that gives us 5 over 6. So this is really 5 to 6. So the scale factor of the smaller figure to the larger figure would be 5 to 6. And that's it. You just have to know which sides are corresponding and then go ahead and write it like we did here. Okay, part C says write a rule to describe each transformation. So we want to know what kind of dilation happened here, or what was the scale factor to go from this black quadrilateral to this blue quadrilateral. Quadrilateral, 4 sides. Okay, so what we have to do is basically we need to figure out the scale factor, and then we'll be able to pick one. Some are written in fraction form, some in decimal, but if you want, you can change them all to decimal. It doesn't matter. Honestly, this one, 1/2, is the same as this one. So let's see if that's the answer, because if so, then we'd have 2 right answers, because 1/2 is the same as 0.5. So my guess is it's not going to be one of those two, but we'll see. Okay, so what you want to do is find a horizontal or vertical length that's part of the shape. So you can see we don't have any vertical lengths made that are part of the shape. So my suggestion is find a horizontal one then. So what you want to do is find those lengths by counting. So this length right here would be 1, 2, 3, 4, 5, 6, 7 and a half. So let's say that it is 7.5. Okay, then we count. We want to use the corresponding side that goes with x prime, y prime, so we'll do x, y. So it'll be 1, 2, 3, 4, 5. So that would be 5. So you have to find two sides that you're able to count the lengths. Okay, so we want to find the scale factor. So remember, scale factor is new over old. Okay, so the new would be the prime. So remember, new has the prime on it. If that helps you, you can always put that. Okay, so the new would be 7.5, and the old would be 5. Okay, so if we divide 7.5 by 5, let's see what it gives us, because we need to probably put it in decimal form. That's probably the best way. So 7.5 divided by 5 goes in one time, divides evenly one time. Let's go, sorry, not evenly. There. Let's see, that would be 5, 25, 0. So it would be 1.5. So this is equal to 1.5. So it was a dilation by a scale factor of 1.5. So it was an enlargement. Okay, so you just need to find two lengths that you're able to actually count. You don't want to try to count the length of this because it's not vertical or horizontal. You don't know how long it really is. Okay, so it needs to be horizontal or vertical lengths that you're counting. All right, part D I put on your worksheet because you're going to need this later when we start solving for missing sides of similar shapes. So something you need to know how to do is cross multiply, solve proportions by cross multiplying. So we want to solve this proportion for n. So you might remember this from middle school. You cross multiply like this. So when you have two fractions that are equal to each other, you can solve for a missing variable by cross multiplying. So n times 4 is 4n equals 7 times 8. So 4n equals 56. Okay, divide both sides by 4. And n is going to equal whatever 56 divided by 4 is. Okay, let's see. It's 14. So n would be 14. Pretty cool. All right, so those are some examples for each part of your CP19 practice. When you're all done with the work that you're putting on your own piece of paper, make sure you turn it into the sub. See you soon.